right? So we are discussing about the mole concept. So in order to have some quantification, for example, you go to a banana shop, you ask for 1 dozen of banana. It means that you need 12 bananas here. So it's a quantification parameter that we use. Similarly, when I'm talking about, consider, for example, I'm talking about carbon dioxide. In this, 1 mole of carbon is participating. In other words, 12 grams of carbon is participating. Whenever you see any compound of carbon, you can definitely see the minimum participation of the carbon. The minimum participation of carbon is 12 gram. So people started thinking, what is this law of chemical combination happening? Wherever I see, at least at the very basic level, 12 grams is only participating. When I talk about oxygen, let us take carbon monoxide. Here, at least 16 grams of oxygen is only participating. So there is some minima that is existing there in participation. So they got to know that when something is participating, it is participating with respect to its bare minimum atomic mass value. I repeat, its bare minimum atomic mass value. There they understood the concept called as mole concept. The person who gave us the mole photo is Avogadro. This person is very pitiful actually. Throughout his lifetime, he was explaining everyone about this concept, but no one accepted this concept at this time. The reason here is that at that time they all were going on the philosophical value. People were saying that, oh no, whatever is placed in this earth is made up of only 5 states of things, like fire, air, water, earth, sky, etc. But he was the first person to tell us that no, everything is actually made up of atoms, and these atoms are very small, as that was provided by Dalton. Dalton said that everything is made up of atom, and this atom is very small, which is indivisible in nature. Many children have this doubt. If you say it is indivisible in nature, how could you say it is having proton, neutron, and electron? You're not dividing them. We say they are present inside the atom. You're not dividing the atom here, right? So Avogadro started understanding that anywhere if an element is participating, it is definitely participating in its minimum atomic mass value. So let us consider this example here. Consider if one marble is there, the weight of one marble, let me say it is 1 gram. I'm going to a shop. In that shop, I'm taking a polythene cover. In that, I'm just placing many marbles. I'm not counting the marbles. I'm just placing the many marbles and I'm putting it on the weighing balance. Okay. Assuming that the polythene cover mass is negligible. Okay. It's approximately very less. Okay. It's negligible. I'm not including it. Now I say the mass is 10 grams. Can you tell me how many marbles are there?
Yes, ma'am.
How many?
10.
10.
Exactly. You can say that 10 marbles are present in this polythene cover. Same logic applies for your mole concept as well. So they understood that one atom of hydrogen is 1.67 into 10 power minus 27 kgs. This was given by mass spectrometer, which was devised by J.J. Thomson. Now, when you take this any compound of hydrogen, you can find this hydrogen is at what is the basic minimum value with which hydrogen is participating? Mass, minimum participation, 1 gram.
Yes, ma'am.
Yes, 1 gram. So one atom of hydrogen is 1.67 into 10 power minus 27 kgs. If I have 1 gram of hydrogen, can't I calculate how many atoms are present in it? Just like your marble
Yes,
case.
ma'am.
One marble is 1 gram, and I'm having 10 grams totally here. You said it's 10 marbles are present. Same logic here. One atom of hydrogen is 1.67 into 10 power minus 27 kg. The minimum value with this hydrogen is participating is 1 gram. So, how much hydrogen should be present in it? Can't be calculated. just by dividing 1 divided by 1.67 into 10 power minus 27, and it is in kilogram, right? So it's 10 power 3 grams. So this is approximately 6.022 into 10 power 23 number of atoms. And that is what people approximate as 6.023 into 10 power 23. And this is what is called as Avogadro number, which is abbreviated as Na. So we are going to consider any
Ma'am,
element. Yes, Pa, tell me.
ma'am, did this number come before J. Thompson or after J. Thompson?
After J.J. Thomson only. J.J.
Okay,
Thomson gave us the atomic mass of hydrogen. And he was, with this mass spectrometer, they were able to find out, determine the different masses of different elements. So, with the help of this mass of the element, they were able to understand what is this Avogadro number. Okay,
okay, ma'am.
right. So, now we are going to understand. So, what do I understand here? Any mole that you're taking, ma'am, I take 1 mole of any element. I underline this word element. Any 1 mole of any element will contain Avogadro number of atoms in it. Definitely, it will contain Avogadro number of atoms in it. Ma'am, I say it's 1 mole of oxygen that also contains Avogadro number of atoms in it. All right, ma'am, I have half a mole of oxygen. Then how many atoms will be there? Half of Avogadro number of atoms should be there, isn't it?
Yes, ma'am.
All
Yes,
right.
ma'am.
So if I am going to say 1 mole of a compound, any compound I'm saying, it will contain Avogadro number of molecules in it. It will contain Avogadro number of molecules in it. For example, I say 1 mole of carbon dioxide is available. It will contain Avogadro number of molecules of what? Molecules of carbon dioxide. All right. If I'm saying, ma'am, it is having 2 moles of carbon dioxide, then what does it just make us to understand? It will contain 2 times of Avogadro's number of molecules of carbon dioxide. All right. If I want to know how many number of atoms are present, how many number of atoms are present, then what would I do? For 1 mole of carbon dioxide, how many number of atoms are present? You said it will contain Avogadro number of molecules of CO2 will be there. With respect to atoms, what should you do? Multiply by the atomicity. I can see 1 carbon is there, 2 oxygen is here, right? So totally how many you have? 3.
3, ma'am.
So therefore I would say the number of atoms that is present in 1 mole of carbon dioxide is nothing but, first it is Avogadro number of molecules. Now each molecule is containing 3 atoms in it, isn't it? I say it is 3 into Avogadro number of atoms. Understood?
Yes, ma'am.
Yes? Okay. Okay. Now we are trying to relate it with respect to the weight concept here. When I say 1 mole of an element is given by given weight divided by atomic mass of this element. Given weight divided by atomic mass of the element. For example, I say it is 1 mole of oxygen. When I say 1 mole of oxygen, how much is its weight?
16 grams, ma'am.
16 gram. How do you say this, ma'am? In my left hand side, I need 1. So in my right hand side, I know atomic mass of oxygen is 16. If I put the weight as 16, only then it will cancel to give me 1, isn't it? Yes or
Yes,
no?
ma'am.
That's the reason people say that mole is nothing but equal to gram atomic mass. What do I mean by this statement? The gram which is equivalent to the atomic mass gives me the moles here. Similarly, let
Okay,
us
ma'am.
let us talk with respect to a compound here. 1 mole of A compound will be nothing but given weight divided by molecular mass of this compound. Do not get confused with this weight and mass and all here. In physics only you need to give topmost priority. With respect to chemistry, you exclude this gravitational concept here. So weight and mass are both the same in chemistry. So when I say it is going to be 0.5 moles of carbon dioxide, what is the weight of this? How much weight does it weigh? How much it should weigh?
22 grams, ma'am.
22 grams. That's right. Because, ma'am, 1 mole of carbon dioxide means the weight should be equivalent to the molecular mass. The molecular mass of carbon dioxide is 44. Then weight should also be 44. But you said it is 0.5 moles of carbon dioxide. So 1 mole of carbon dioxide is nothing but 44 grams. Then what about 0.5 moles of carbon dioxide? Is a half of it, isn't it? Which is nothing but 22 grams. Understood?
Yes, ma'am.
Right. The next one. Okay. Now this was with respect to weight and the mass. What if I'm talking about the ideal gas? 1 mole of an ideal gas at STP conditions. That means at 273 Kelvin and 1 atmospheric pressure will occupy 22.7 liters.
Ma'am, isn't it 22.4?
44 only, sorry. Not 7, sorry. 22.4 liters. Okay, so if I am having 44.8 liters of carbon dioxide, how much weight does it carry?
88 grams, ma'am.
Huh? 8 is very good. 44.8 is nothing but 2 moles, isn't it? 22.4 is 1 mole, then 44.8 is 2 moles. 1 mole of carbon dioxide is 44 grams. What about 2 moles of carbon dioxide? 88 grams it is. Understood?
Yes, ma'am.
Yeah. So we understand that more is the weight is directly proportional to moles. Moles is directly proportional to number of atoms, which is also, I can also say it is number of molecules of it, right? I'm having N3 minus. How many electrons does it have?
10, ma'am.
All right. If I'm talking about one atom of it, one atom of N3 minus will have 10 electrons, right? I didn't mention one atom. That means it is 1 mole of N3 minus, isn't it? So can I say it is 10 into Avogadro number times of electron,
Yes, ma'am.
right? So this is a basic concept about your mole for you. With this, you will start solving the first problem. Yes. Keep solving. I'll be in a while.
எப்படி இருக்கும்மா வீட்டில்
Ma'am, is it option B?
மம்மி ஏதோ கேட்குறாங்க நீ லேப்டாப் கிளாஸ் போயிட்டு இல்லை நீ மெசேஜ் பண்ண எப்படி தெரியும் நான் வண்டி ஓட்டுறேன் ஒரு ட்ரெயின் செய்யுங்க ட்ரெயின் எடுத்துக்கலாம் வா இதை எழுது இதை எழுது வா சாப்பிட்டு வந்து எழுது
வெடி எடுத்து ட்ரெயின் எங்கடா 2 minutes already கலரி விட்டுறது. Yes, da. What's your answer, pa?
C, ma'am.
C, yeah?
Ma'am, C.
Okay. Let's check your answer. That's right. Very good. Let's go for the next question. Yes. Go on.
Option A, ma'am.
You, Midula, shall I click C? What's your answer?
Yes, ma'am.
A, ma'am. A.
A. What's your answer, Midula?
Ma'am, I'm still solving.
Still solving. Okay, let's give her some time, da. You can go for this question. Have you practiced empirical formulas? Nitish?
Huh?
Have you done empirical formulas in your school?
Yes, ma'am.
Okay, then keep solving it. Mithila, are you ready with your answer?
Ma'am, can I see the options again?
Yes.
Yes, ma'am. A.
Yay. How is it? Both of you have given me the wrong answer. Huh?
No, it is same, man.
Huh?
We got A and B as both same number of molecules, atoms.
How come da? Did you multiply with atomicity? There are 3, na? 1
Uh,
sulfur, 2 oxygen. We just now explained for carbon dioxide, na? 1 carbon and 2
yeah,
oxygen. 3
right.
times it should have got multiplied.
Yes, ma'am.
Repeat it one more time. How come you missed C and E then? Even though you have done A and B, if you have missed it, how did you miss C and E? Repeat the question.
Yes, ma'am. D correct, ma'am.
Poli சாப்பிடு poli. Poli சாப்பிடுங்க. Got the answer?
Yes, ma'am.
Okay, good. What about you, Midula?
Solving, ma'am.
Solving? Okay. Please complete and then move for the next question. If you have any doubts, please let me know. Yes. Before we solve this, I will discuss you regarding this empirical formula calculation and then you can start it. Okay. We are discussing about the empirical formula. So empirical formula is nothing but the simplest way or simplest form of the compound. For example, I have hydrogen peroxide H2O2. Both are having the same number. I just divided by 2. So I say it is HON times. So this N is nothing but the molecular mass divided by empirical mass. Molecular mass divided by empirical mass. It's the first equation that we have to remember here. When you get this N value, when you multiply it with the empirical formula, what you get is a molecular formula. The N multiplied with respect to the empirical formula gives us the molecular formula for us. Number 3, 2 multiplied by vapor density. 2 times of vapor density gives the molecular mass of the compound. So these are the 3 set of formulae we have to remember in order to calculate the empirical formula. Now the very common way of asking you to solve this empirical formula is providing you with respect to the mass percentage of carbon, hydrogen, oxygen, etc. So in that case, what should I do? Step number 1, check the given mass sums to 100. This is the first step that you have to do here. What you have to do? You have to just check whether the given mass sums up to 100 here. We are discussing the empirical formula here. Empirical formula is the simplest form of the compound that you express. I have hydrogen peroxide here. This is 2 times at both the places. So I say it's HON times, but the N is going to be 2 here. So N is nothing but the molecular mass divided by the empirical mass. When you multiply this n factor with respect to empirical formula, you will find the molecular formula. 2 times of vapor density will provide the molecular mass. The very common way of practicing the empirical formula calculation is that they would provide you the mass percentage of these elements. Step number 1, total their mass and check whether it is equal to 100. Once it is equal to 100, you can understand it is in percentage with respect to 100. For example, they will give you carbon is having 12 percentage, hydrogen is 1%, let me say it is a 3 percentage, oxygen is some 1.5 percentage, like this. So step number 1, you have to calculate the moles of it. How do you calculate the moles? Weight divided by the atomic mass, carbon, hydrogen and oxygen. So the given weight is 12, the atomic mass of carbon is also 12. The given weight of hydrogen is 3, the atomic mass of hydrogen is 1. The given mass of percentage of oxygen is 0, that is O is 1.5, 1.5 divided by 16. So whatever you get out of this, the least value that you have obtained, divide throughout by this least value. Now you will get the minimum moles. What will you get? Is minimum moles. Now, for example, I am having C is here, 2 it is here, H is some 1 is there. Now oxygen is something 0.5, I get it. For example, we are not getting from this calculation, I am just telling you. You have never seen the compounds having this kind of decimal values, fractional values. Yes, you will be able to see it in a very rare complexes which are called as interstitial compounds, but these are not that kind of compounds. In that case, what will you do? You have to multiply it by some number so that this becomes a whole number. I know 0.5 into 2 will become 1. So what will I do? I will just multiply throughout by this 2. C4H2O. That is the formula of this compound. Got it? This is how you calculate the empirical formula of this compound. So what you get here right now is the empirical formula. Now in order, if they are asking you for the molecular formula, what will I do? They will be providing you with molecular mass here. They will be providing you with molecular mass. From this empirical formula, you can calculate the empirical mass. Isn't it? So can I calculate the n from that? Molecular mass divided by empirical mass will provide me this n factor. Now take your empirical formula and multiply by this to get the molecular formula of the compound. Is it clear till this for both of you?
Yes, ma'am.
Right?
Yes, ma'am.
Yes. So let's solve the question. Based on the logic that I have given you, solve the question. Yes, go on. Pranur இருக்காளாப்பாங்க? அப்போ அங்கே யார் பார்த்துட்டு இருக்கா? நீ தான் பார்க்குறியா? நீ என்னைக்குப்பா சாம்பார் சாப்பிட்டு தொட்டிருக்க? ரசம்னா நீ சாப்பிட மாட்டேன்னுவ. Lock the door and leave. ஹலோ, அது நான் சொல்லணும். கதவு லாக் பண்ணிட்டு போப்பா, ஃபேன் போட்டு போப்பா.
கிளாஸ் சொன்ன என்ன பற்றி கவனிச்சிருக்கிறேன்.
JEE advanced ஊத்திக்கிச்சு ஒருத்தனும் குவாலிஃபை ஆகல ஜெகனை போட்டு தாளிச்சாங்கப்பா என்ன பண்ணிட்டு இருக்கேன் ரிசல்ட் வந்துருச்சு ஒண்ணு கூட சொல்லவே இல்லை இன்னும் என்ன ஆச்சு ஏதாச்சுன்னு எதுவும் குவாலிஃபை ஆகல அதை போய் என்ன சொல்றதுன்னு ஓ, அப்படியா வாங்க ஸ்கூலுக்கு அப்படின்னு சொல்லிட்டாங்க சொட்ட ஆமா அப்படிதான் என்னதான் மத்த 2% சப்ஜெக்டோட உண்டு அதிகமாவே இருந்தாலுமே உனக்கு கொடுத்த கேஆர் நீ கம்ப்ளீட் பண்ணலையேன்னு சரி அவங்ககிட்ட எல்லாம் போய் நம்ம கேட்டுன்ற கூடாது நான் தான் என்னைக்கோ பிளான் பண்ணிட்டேன் அவங்ககிட்ட கேட்க கூடாது இதை விட அதிகமா நம்ம போயிடுமே கண்டி இவங்க எல்லாம் போய் நின்று நீங்க கொடுங்க எல்லாம் கேட்க கூடாது அவனே அந்த மெரிட் பார்த்து கொடுக்குறமே கண்டி நம்ம கேட்க கூடாது.
Ma'am, is it B?
Okay, let's check whether it's B or
C, ma'am.
B is the right answer. Why did you say C, da? How did you do that? Tell me. They have provided you percentage, da. So I can understand it is mass percentage, correct? So out of
Yes, ma'am.
100 grams, 69.9 gram is iron. What about oxygen then? The remaining
30.1, ma'am.
30.1. Okay. Now we will calculate the moles of it dividing by its atomic mass. Now from that you will divide it by the least number. This is my least number, right? So when I
Yes,
divide it,
ma'am.
you will get 1 is to 1.5. Now what will you do? As I told you, I have to multiply by 2 so that I complete it into a whole number. So it is Fe2O3, isn't it?
Yes, ma'am.
Understood? Ah?
Understood, ma'am.
Either you do it by this method. If not, children, what they do is that they take the compounds itself. I mean, Fe2O3, 2 moles of Fe is there. 2 into 56. So 2 into 56 is 112. So 112 divided by total weight into 100 is 70 percentage, which is almost equal to 69.9 percentage, correct? Then it has to be Fe2O3
Yes, ma'am.
only. Two ways of doing it. Actually, the second method is easier, but only one problem is that you have to keep on looking for all the choices, all the four choices,
Okay, ma'am.
right? But here also we can eliminate. Ma'am, it is 70% of iron. Obviously, option A cannot be there. You can see 50% is there, both of them. So eliminated. In option C, I can see iron is too much. It's equivalent to oxygen. It's 4 and 3, and it couldn't be that much here. And it is FeO3 here. Iron is too less. So the competition has to be only between B and C. So you could check this method, second method, for B and C alone. Clear na?
Yes, ma'am.
Right, very good.
Yes, ma'am.
Right, let's go for the next concept. We are discussing regarding the concentration terms now. I would say it's like a backbone for the physical chemistry here. Number one is a volume by volume percentage, mass by volume percentage, mass by mass percentage. Let us discuss this mass by mass percentage. It is mass of solute divided by mass of solution into 100. So if someone is telling me it is 20 m by m percentage of NaCl, what do I understand from here? It is 20 grams of NaCl in 100 grams of solution. So what do I understand here? There is 80 grams of water in it or solvent is present in it, right? Same logic goes for the other ways also. Mass by volume percentage. When I say it is mass by volume percentage, mass of solute divided by volume of solution into 100. Volume by volume percentage, volume of solute divided by volume of solution into 100. These are the very preliminary ways of expressing the concentration terms. But you can definitely see these concentration terms that are provided in all the uh, eye drops, ear drops, or even your skin ointments. They will be definitely providing you this percentages only. Mass by volume percentage, volume by volume percentages, etc. The next concentration term is called as molarity, which is given by the symbol capital M. So this is nothing but number of moles of solute divided by volume of solution in liters. Number of moles of solute divided by volume of solution in liter. So when someone says 1 molar solution, it implies that 1 mole of solute, 1 mole of solute in 1 liter solution is there. That's the meaning here. So if I'm saying 1 molar sodium hydroxide solution, I can understand 1 mole of sodium hydroxide in 1 liter solution is present. 1 mole of sodium hydroxide is nothing but 40 grams of sodium hydroxide, isn't it? Because a mole is nothing but its molecular mass itself. Can I say that?
Yes, ma'am.
Yeah. So the very common way of questioning is here asking you to find the weight of solute present in 2 molar solution of HCl in, let me say it is going to be 500 ml solution. This is a very common way question that we have. But remember, JEE never just gives it only one single question. You just saw the two questions here. In order to get that 1 4 mark, you have to solve many of them to get that 1 4 mark, isn't it? So here they are providing you the molarity, they provided you the volume of the solution. You're asking for the weight of the solute. So just substitute molarity is equal to weight of solute,
Ma'am, it's 36.5.
correct? Volume of solution in liter. Substitute for molarity is 2. Weight they are asking. Volume of solution is nothing but 500 ml. But I need it in liters, right? Correct?
Yes, ma'am.
Yes. So it is 1 by 2 and HCl is 36.5, right? And then what should be weight? 2 into 1 by 2 into 36.5, which is nothing but 36.5 gram itself. The next way of question is with respect to the calculating millimoles. I said moles is equal to molarity is equal to moles divided by volume of solution in liter. In case here, ma'am, for example, they have provided the volume in ml, ma'am. So when I multiply molarity into volume in ml, what will I get? I will get millimoles. I'll get millimoles. Molarity multiplied by volume in ml will give me millimoles. Millimoles is nothing but equal to 10 power minus 3 times of moles. Understood this?
Yes, ma'am.
Alright. The next thing that we have to remember about this molarity is dependent on temperature. Molarity is dependent on temperature. You can say molarity is equal to moles of solute divided by volume of solution in liter. Consider I'm just warming. Example, I am just warming the solution. I'm not boiling the solution, warming the solution. As I warm the solution, what would happen? What would happen? The liquid molecule is going to absorb the heat. As it absorbs the heat, what should happen? Kinetic energy should increase. As the kinetic energy is increasing, slowly there will be a little bit expansion in their volume. Can we say that? You understand both of
Yes,
you?
ma'am.
Yes. So if there is an
Yes, ma'am.
expansion of volume is available there, consider molarity is inversely proportional to volume, but volume is directly proportional to temperature. So can I say molarity is inversely proportional to temperature? Can we say this?
Yes, ma'am.
Yes, ma'am.
So this is another question that you could definitely get. 2025 JEE mains also provided you the same type of a question here. Molarity dependence with respect to temperature. Okay, so this is with respect to molarity term. The next term is called as normality. Normality is nothing but equivalent moles of solute divided by volume of solution in liters. The only difference between the molarity and normality is molarity was concentrating on moles. Normality is concentrating on equivalent moles. What is this equivalent moles? Consider we said molarity is equal to weight divided by molecular weight of solute into volume of solution in liters. Instead of this molecular weight, if I am going to write equivalent weight instead of molecular weight, if I am writing equivalent weight of solute, then I call this as normality because what you're seeing right now is what is called as equivalent moles. Equivalent moles is equal to weight of solute divided by equivalent weight of solute. Not just solute, you can say weight divided by equivalent weight is nothing but equivalent moles here. Okay.
Yes, ma'am.
Now we are trying to redefine with respect to molarity here. Ma'am, what is this equivalent weight? It is a molecular weight divided by n factor. Let us explain this. The molecular weight of HCl is 36.5 gram. Equivalent weight of HCl is also 36.5 gram. What is the n factor here?
1, ma'am.
1. Correct, that's right. N factor is 1 here. If I'm going to just substitute equivalent weight, which is 36.5, molecular weight is also 36.5. What should be my n factor then? N factor should be 1 here. So how do I define the n factor for an acid? The n factor for acid is nothing but number of transferable H plus ions. HCl that is protonating in water will release one H plus ion. Consider sulfuric acid. How many H plus it will release?
2, ma'am.
2 H plus ion. So therefore, for an acid, n factor is equal to the number of transferable ions. So consider The equivalent weight of sulfuric acid. What will be the equivalent weight of the sulfuric acid? Mridula, what will be the equivalent weight of sulfuric acid, Ra? The molecular weight of sulfuric.
49, ma'am.
Correct, Ra.
49, ma'am.
That's right. 98 divided by 2, which is 49 grams. Correct?
Yes, ma'am.
Right. So we are going to, so look at this. This equation I'm taking. What is equivalent weight? Molecular weight by n factor, right? Let us rewrite it. Weight of solute divided by molecular weight of solute divided by n factor into volume of solution into liters. Correct? All right. So
Ma'am,
this is, tell me, pa.
ma'am, why do we need normality, ma'am? Like, what's the use?
Normality is a concentration term which is beneficial for redox reactions where the n factor is involved, not for common
Okay,
reactions.
ma'am.
For redox, we use it. Okay, you can see this n factor is denominator to denominator, so it can raise to the numerator.
Okay, ma'am.
Okay, let me raise it to the numerator. Then redefine the same equation here. And redefining this equation, weight of solute divided by molecular weight of solute into n factor into volume of solution into liters. So have you seen this equation already?
Yes, ma'am.
What is
Yes,
this?
ma'am.
Is this molarity?
Yes, ma'am.
So I have molarity into n factor is nothing but equal to normality. Okay,
Yes,
right. So we understood that, for example, I'm telling you, uh, it is 2 molar sulfuric acid. Then what is the normality of it?
4, ma'am.
4. Very good. Because molarity multiplied by n factor will give me the normality, isn't it? So it has to be 4 here. Okay. I just said normality is like nothing but equal to equivalent moles divided by volume of solution into liters, right? So what is
Yes,
equivalent
ma'am.
moles? Can I just calculate it by number normality multiplied by volume of solution into liters?
Yes, ma'am.
Right. If it is going to be equivalent to millimoles, or people very simply we generally address it as milli equivalent. Milli equivalence shouldn't be equal to normality multiplied by volume of solution in ml.
Yes, ma'am.
Right. So this is with respect to the normality that we have got. The next concentration term that we have is mole fraction. Next concentration term is mole fraction, which is given by the symbol chi. Now just understand the word itself. It's a fraction of a mole. That's the meaning here. So when I'm talking about a solution is basically made up of solute plus solvent, right? So if I'm talking about the mole fraction of the solute, remember chi is mole fraction. What do you mean by the fraction of its mole? So when I say it is a mole fraction of solute, I understand there's a moles of solute with respect to total moles. Can I say this?
Yes, ma'am.
What is this total moles? Isn't it the moles of solute plus moles of solvent?
Yes, ma'am.
Right. All right. So what will be the mole fraction of solvent then?
Number of moles of solvent by
Hmm.
total moles.
Correct.
Number.
Correct. So I'm just going to sum it up. Mole fraction of solute plus mole fraction of solvent. Just sum that up. What do you get? Number of moles of solute plus number of moles of solvent divided by again number of moles of solute plus number of moles of solvent,
1.
Yes, ma'am.
which is 1. I say mole fraction of solute plus mole fraction of solvent is equal to 1. In other words, can I say the mole fraction of solute is 1 minus the mole fraction of solvent?
Yes, ma'am.
This is the next concentration term. Mole fraction. Okay. With this, let's solve this question.
Fourth question, ma'am.
This one, fourth one. You can see the screen, right?